Fine. So last class we saw what are random variables and we saw discrete random variables. I hope you all were in the same page with me. Today we'll be seeing what a continuous random variables are, and in particular we'll see some fun questions to deal with continuous random variables and so on. So uh, as you had seen last time, so a random variable was a mapping from, as you can recall. So 19th of March. Okay, it was a map, a random variable X was a mapping from the, do you recall, from the sample space to the real number line. So you had an experiment where if this was your sample space, every element in this sample space was mapped to a number in the real number line. What did it help us to do? It helped us to find out, so was some small x, which belongs to R, which helps us to do a lot of computations like expectations and so on. Yeah. So what this was, we saw it for only when x equal to 0, x equal to 1. That was a discrete case that we solved. That we saw examples like the geometric distribution, and we saw the Bernoulli, the binomial, and so on. Today we'll be having an idea of what happens if the state space is a continuous random variable, as in, so every element is mapping into a continuous set, that is R in R, which is non-countable by what I mean by a continuous space, as you all know. So everything we will try to find out the analogous definitions, but let us first try to understand what would be the probability of x being equal to a number b. Say you have, if it is a continuous random variable, so just being equal to a number, intuitively, what is it going to be? Like if I'm given a scale between 0 and 1, and I'm telling you to randomly select one number between 0 and 1, what is the probability that you'll get exactly 0.555? Any idea? So for example, I'm selecting between 0 and 1. In computer science, you do it all the time, that you use the uniform or rand int function. Whatever Java, C++, C, whatever you use, this is rand function samples uniformly between 0 and 1. So I'm saying that what is the probability that you get a single value which belongs to the real number line between 0 and 1? Can you tell me? So if you take that every element here is equiprobable, so there are, so just from intuition base, this denominator, since it is equiprobable, we can use the naive definition. The size of the set 0, 0 to 1, followed by just one x, that is one value. What is the size of this set? Numbers, real numbers in between 0 and 1. Am I audible?
Infinite.
So it's infinity, right? It's uncountable. So this, a random variable being equal, what I'm trying to get at is a random variable being equal to one number is infinitesimally small or 0 in our case. So for continuous random variables, when the output space is continuous, you can't have a random variable being equal to a particular value. Is this fine? Any questions? Please ask. I think if I'm not audible, please get back to me as well. Fine with everybody?
Yes.
Is my connection all right? I just got disconnected for a moment.
It's all right now.
Okay. So is this thing clear? Any question from anyone?
It's
Okay.
clear.
Fine. So we have understood. So I would expect that people just, since again I said last time that it's an online class, I can't see your faces. I will not, it will be very difficult for me to understand if I'm conveying the information correctly. So if you have any ounce of iota of doubt, please stop me there and there. So could you give me an idea, or um, what would your strategy be to get a non-zero number as a probability? Because we are seeing that a number. So let us take an example. For example, a random variable which is continuous time would be time you wait in a bus stop, right? So you arrived at a bus stop. So this is the time, and say this is the probability of t. We'll come to what t will be, but let us say that is some probability of some functions of t. So you will expect as you wait, the probability of waiting more will decrease, where t is time to waiting, time for bus to arrive. Or rather, it's the other way around. Time you need to wait. So as time increases, the probability that you have to wait should also decrease. That's like an ideal world. That's what I'm trying to say. So, but exactly at a particular moment in time that the bus arrives, that you can't really say. Instead of that, I can say that what is the probability that the bus arrives in a 10-second window? That is much more like feasible, right? That's a similar. So now we can compare between same dimensions. That's what I'm trying to say. I'm getting at calculus. So what I'm trying to say is, so instead of trying to say that what is the probability of x is equal to x, we will try to answer this question. What is the probability that if it is a continuous space, it is between x and some x plus delta. Fine. Limit delta tends to 0. This I can do, right? This would have a meaningful output. Fine. So this is what we define as. So this, when the function that we use to calculate this is defined as the density function. Density because as you know, if you take a volume, infinitesimal volume, and multiply with the density, you get a mass, right? Similarly, density into a volume will give you a probability. Is it clear? So this is the integral of x to x plus delta, some function, which is the density function of the random variable x dx, right? To approximately equal to, since delta is tending to 0, I can put the value of x, assuming it is a well-behaved function, to delta, right? Is it fine? If there's a confusion, I'll replace x with a. Take a is a number, so f of a. And this is known as the density function. So is it clear? So if you see this graph over here, you're literally taking the integral of the area under this curve. That this area under, so this is the density curve. Density curve. Area under the density curve is the probability. I hope I could make it clear. Is it clear to everyone? So if it is clear, I have a question for you. Tell me what would be the probability of a random variable being between two values x between a and b. Can you tell me? Given density f of x exists. Any questions? Any idea how to do it? So if between x and a plus delta, this was this integral between So as I told you, the area under the curve will give you the probability. So what will be the probability for a random variable being between A and B?
f of x b minus f of x a.
No, f of x is the density function. I'm taking the integral, right? So you have to get
The
so
integration of a to b f of x.
correct. You are right if you are taking f, that f to be capital F. That is the integral of the value. This is right. So you see
Yes,
this. Yeah, it's just the density. So between A and B, it is just say this is A, this is B. This is just the area under the curve. So this is why how density functions are defined. Density function, it's also called the probability density function. Function or the PDF. So in your exams, if they ask you what is the PDF, this is the PDF. But we'll see how is the PDF related to everything. But we are understanding that if we given a PDF, we can find all probabilities, right? That's the idea. Now let us try to relate this continuous random variable to this, again, this idea of this sample space, and that a random variable is just a function from the sample space of the real number line. So for that, I have a question for all of you. So what would be the integral between minus infinity and infinity f of x? So first tell me what is the, I have to prove that it is equal to 1. Can you tell me how do I do that? Like what would be the first step to do this? There's a hint. Hint is in this box. That you have over here. So minus infinity to infinity means this integral means the random variable x is between minus infinity and infinity, right? Do you agree?
Yes, 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 sir.
Great. So what does this mean? We have defined when we talk about this event, what is a probability function actually defined on? Recall. What did we say? The probability of x belonging to a region A was equal to, because you remember, right? The probability, what is the P of P defined on? Last day we said P is a mapping from the event space to 0, 1, right? An event space is subsets of the sample space. Please go back and see this. So any subset of the sample space would have a mapping. So P of x belonging to A means these are all values in the sample space. All omegas in the set omega or the sample space such that x of omega belongs to A. Is this clear to everyone? I'm just revising what we did last time.
Yes.
Okay, so this probability function, so if you have it is clear, so what will minus infinity to infinity mean? It means that x belongs to R, right? And we define that this is equal to x inverse of A, where we said that this, if this is the set, everything that it's a pre-image of, this is the x inverse, the pre-image in the sample space, and we use the measure on that, or whatever the probability function on that. Sorry. Right? So what is this? This is P of x inverse R. So now if I ask you what is P of x inverse R, what will you tell me? The entire number line, if I take a projection back, what is the definition of a random variable? Omega to R, right? If I take a pre-image of R, the entire real number line, what will I get? I'll get omega, right? The entire sample space.
Yes, sir.
Anything. Yes. So please, everybody again who was not here, please don't call me sir. I'm just a few years senior than you. Please call me Dada, or just call me by my name, Moinak. So this is 1. So what I'm trying to say is, when we are taking this inverse, so any value on the real number line would exist on this in this set. So if you take a pre-image, they will exist in the omega set. So this is why the integral from minus infinity to infinity of the PDF is 1. Right? So we understood the property of the PDF or the density function. Now, in continuous distributions, the PDF actually may not exist. So there are some functions where you will have discontinuities and jumps, for example, the ones that we did yesterday. For example, discrete functions, they would not, PDFs won't exist. So the cumulative distribution function, or the CDF that we discussed last time, is a more fundamental property. So this is a more fundamental, let's see, more fundamental property of any distribution, which always exists. So this is a CDF F, which is a CDF maps from the real number line between 0 and 1. And it is a monotonically increasing function, as we have seen. We'll see it again. Let's see. Okay. So now what do I do? So I do things like, so I try to relate what is the CDF and the PDF going to be related. So let us relate it. So how is the CDF first of all defined? So it's again, you can define it from R, because your random variable is between omega and R. So it's between a random value in R to 0, 1, which is the probability, which we drew last time. Sorry, I wrote omega, but X there, but X is actually the mapping between omega and R. So for a random variable X, given a value X, which is this is the scalar. This subscript is the random variable, which you are not going to change. This is the function, the small x. So how do you define it? We have seen it last time. This is the probability that the random variable X is less than a scalar or a value you are trying to manipulate, that is small x, right? Fine. So don't, there is a little bit of an overloading of notation over here. This, whenever I'm writing this script X, this is a number. And whenever writing capital X, this is the random variable. Okay. So if this is between minus infinity, this is X less than X. So what can I write? How can I write this in terms of the CDF or the density function, if it exists? So we define that P of X less than X means X is between minus infinity to X, right? Which means
integral of minus infinity to 0 x. Okay.
Yeah, the density function. So this is how you define it. Good. Or it's true. Fine. So what I now want to do is I want to relate them in a, so integral one I know already. I want to show that the derivative of the CDF is the PML or is the PDF. How can you tell me how can I do that? So if I take the derivative of f of x dx, what will I get? D dx of minus infinity to x f of x. Let me write a different variable over here. Yeah. What will I get? Do you recall this formula, or do I have to use the fundamental theorem of calculus? Do you know this formula? This is the Newton-Leibniz formula. Okay, let's do the Newton-Leibniz formula so that you remember for the rest of your life. Fine. So this formula tells you, say you are trying to take a derivative of an integral, right? Say a function that is given g of x or g of y, because we want to integrate it out. The limits of the function are from between f1 of x and f2 of x. Okay. So what can you write this as is the question. You can write this as, so let us say that the integral of or the derivative of a capital G function with respect to x is g of x, right? So by the fundamental theorem of calculus, what can I write this equation as before the thing that inside the derivative? The integral of small g of x is capital G of x, right? Y between f1 of x to f2 of x. This is the fundamental theorem of calculus, yes or no?
Yes.
Yes.
So now if I take the derivative, I already have the definition of the derivative. So I can just put, so g of f2x minus g of f1x, and you take the derivative with respect to x. So what do I get by chain rule? I get small g of f2x into f2 dash of x minus small g of f1x into f1 dash of x. Yes or no?
Yes. Yes.
So now
Yes.
if it is okay, so how can I write this equation? So from the fundamental theorem, so this is the Newton-Leibniz formula. So Newton and Leibniz both discovered it independently actually. So now if I had to take the derivative of this, just tell me what will it be. So the trick is you just put the limits of the integral into the integral.
This is just f of x, means if
Correct.
capital X of x from small x.
Cap of capital X of x and ddx of x is equal to 1 and minus 0 because the denominator is a constant. Constants will just become 0. So that's why when you have a constant integral, this will just become 0 because the derivatives of the constants on a and b would be 0. Fine. So now I see that the derivative of the CDF is the density function. So we have a nice relationship. Next, yesterday let us just see a few things. And do you remember, do you recall what was the definition of discrete case? What was the definition of expectation of a random variable? Which x was discrete?
Summation capital X f capital X of x.
Yeah, x equal to x, right? Or k, right? So all the values of the random variable, because we saw it, we proved it by taking a sequence. But now since you see this, how do I replace it with expectation in CDF in a continuous space? Can you tell me using calculus, your calculus type of idea? Something like a Riemannian sum we can do, right? So we can do this, right? So where we can write for a continuous variable, expected value can be extended as limit delta tends to 0. The limit, so you have this value, right? This intermediate value, whatever you're trying to write, you're trying to find out this area, right? Isn't it? And you're doing the Riemann sum, correct? So this will be P of x belonging to k and k plus delta. Yes or no? Fine. P between k and k plus delta into the value of k. Yes or no? This is fine. This is just the extending to the continuous case. I'm just extending this to the continuous case. It is fine.
Yes.
So now, if this I can already write as f of x k into delta. Yes or no? We have seen this. We already proved it. If delta tends to 0. Correct? I hope
Yes.
this is fine. So this is going to be just the integral. So delta becomes delta x. So this becomes x f of x dx as delta tends to 0. Between minus infinity to infinity. I hope this will remember. So anytime there is a summation, you convert it into an expectation like this. Fine. So now using this formula, you have to show this property. I'll just copy this. Solving this question will give you an understanding of how to use this integral, basically. That's why I brought it. This is all the foundations. After this, we'll just do some maths and then do a computational. We'll do a question in Python and then we'll stop. But it is this is the fundamental thing you should understand. So I'm trying to tell you that normally I told you expected value of x is the integral of x f of x dx between minus infinity to infinity. Now I want to relate this integral to the CDF. So this is the with respect to PDF. If I have to, so remember that this PDF is analogous to PMF in discrete case, as you can clearly see, because everything where there was PMFs has been replaced with PDFs. But anyways, so let us try to replace this with the f function. So can you tell me how do I do this? Can you give me a hint? The hint is integration by parts, but you have to really use your brains a bit. So see, do you agree df of x df is f of x dx? Right, the differential is this. So I can write this as minus infinity to infinity x dfx, right? Yes or no? Fine.
Yes.
So now, between minus infinity to infinity, see, there are two conditions. When there is a proof, what you try to do is try to see the conditions. One is x greater than 0 and one is x less than 0, right? So let me break this integral into minus infinity to 0, x dfx, and infinity to 0 to infinity, because this is x greater than 0 condition and this is x less than 0 condition. 0 to infinity. Can you tell me? So there is this 1 minus f of x here. So what should I replace dfx to be? Do you mind if I write this as this? So my idea is dfx is same as d of 1 minus fx, negative of it, right? Right, basic calculus. Now I do integration by parts. What will I get the first part to be? Which one should I integrate? Which one should I differentiate? I integrate this, right? So I get x fx minus, so I differentiate this, so I get 1 times f of x dx from minus infinity to 0. Fine, you agree? And this is between minus infinity and 0. So tell me what will the first term be between minus infinity and 0? This term. What is f of x at minus infinity?
0.
0. Why?
0.
Because x cannot be less than minus infinity, because x is a mapping from real numbers to random variable. So it is defined at minus infinity to be my 0. So this term is 0 minus 0, right? Sure. And only this term remains, that is x less than 0, f of x dx. Similarly, we can also do it for this, and you will get x greater than 0, because there is already a negative. This negative will be consumed and you will get x greater than or equal to 0, 1 minus f of x dx. Similarly, why did I take this? You will appreciate it if I do the first part. See, x into 1 minus fx dx, right? It will be the first part of the integral, again from 0 to infinity. Do you agree that fx of infinity will be equal to 1? Right? All values, which means that probability x less than infinity anyways has to be, it is defined as 1. Right? All values are, any random variable is a mapping from sigma, the sample space to the real number line. So it has to be less than infinity. So that is equal to 1. So at infinity, this term again becomes 0. That's the reason we took 1 minus. Is it clear, the manipulation?
Yes.
Yes.
Yeah. So let us do one question. I had not planned to do this, but let's do this nonetheless. This maybe will revise the concepts that we did. So I want to prove that if x of x is monotonically non-decreasing. That means it is either increasing or remains constant for some places. Can we prove this? I think we have proved one theorem that can be used here. We have proved the monotonicity of sets last time. So let us first try to say, let us take 2 points. I will construct the proof because you are so young students. It's a bit difficult in school, so you don't learn how to do proofs that much. So let x comma y be 2 points. Though this is without loss of generality, be 2 numbers such that y is greater than x. Fine. Let us draw the real number line. So this is x and this is y. Fine. Yes or no? Okay. So now I tell you, what do I have to show? I have to show that, need to show fx of x is less than fy of fx of y. Yes or no?
Yes.
Because x, my monotonicity means if x is, so it is something like this. It also always has to increase, something like this, between 0 and 1. So this is the example of f of x. So whenever you have a monotonic function, try to remember this graph, a similar graph. This is x and this is y. This is f of x. This is f of y. Since if you not are able to visualize, draw this and visualize. Fine. So now, how can I prove this? I can prove this by taking this right-hand side. So let us take fx of y. What can I write this as? Probability of x less than y. Yes or no? Which means that these are all the events omega in the sample space such that x of omega is less than y. Yes or no? This is the definition. So I'll draw the sample space here. So say these are this element. This is the set. So let us write as a of x. I'll just write this as a of x. Or rather a of y. Sorry, because we're doing y less than y. So let us take this as a of y. Correct? So now, do you agree to me that I can rewrite this as omega belongs to omega, x of omega less than x union omega belongs to omega, x of omega belongs to x and y. Can I write this as this? Right? Because again, I'll draw the function nicely so it will be easy for you to understand. This is x minus infinity, infinity. This is y. So I'm saying this is a of y. This entire thing that I've drawn. Since if x is less than y, say a k is less than y, it implies that k is less than x. Yes or no? Oh, sorry. If k is less than x, it implies k is less than y. Yes or no? Correct? Is it clear? So if a number is here, that is less than x. This is k. If that is less than x, that also means it is less than y. That's the idea I'm trying to formulate. So this entire set will be a subset of this y. Yes or no? So this will be a of x. And this will be a of y without a of x. Fine. That is this a of y without a of x. And this is a of x. Please go back and see the definition that we did it last time. So this is p of ax union p of ay minus a of x. So this is p of ax plus p of ay minus a of x. First, how did I get from here to here? By exclusive events. These are exclusive events. That's how I got from here to here. And this is greater than 0. So what will I get? This term is fx of x, and the right hand side is fy of y. Yes or no? This is fy of y. Do you agree?
X তো common আছে। X is common for both cases.
Yes, x is common for both cases, and you have an extra set between x and y, right?
Yes, sir.
Yeah. So this means that's what I wrote. So this is all the set. This one, this a of x is nothing but fx of x. And this is the extra set, that is probability between x and y. You are absolutely right. You could also have written it like this, as you are saying. So if, let us write this as alternative, but the previous one is just to revise your set theory and the axioms of probability. But this is one also, you can write this in a similar way. If y of y is the integral between minus infinity to y, fy of y or fx of x, which is same as minus infinity to x, sorry, not y, fx of x dx plus the integral of x to y. This is what you were trying to say, no?
Yes, yes.
Shayon, yeah, Shayon. So this is also greater than 0. So it means that this is f of x, not y, sorry, again. So f of y of y, f of x of y is greater than f of x of x. So this is monotonic. So this always will keep on increasing. Fine. So we are done with all the theory. Let's try to, so this is also done. Not this, sorry. This is done. So now let us try to see what happens if there is a transformation of a random variable. That is a function like this. Let us take very simple function. I'll give examples and it will become very simple for you. But yeah, but currently let us take any function. Say a random variable y. I'll just do it in a small place here. Yeah, say a random variable y is a function of f of x. Do you agree that x is a random, x is again a mapping between omega and r, right? So x is also a function, right? So now y is a composition of this, right? Yes, yes or no? Of both the random variable and the value. So that's why we can just write this as f of x. Whatever the random variable takes, for example, f can be x square. So if the random variable gives you value 2, your f of x y will become 4. Similarly. Now I tell you that y f is monotonically increasing. You have to prove a relationship between y and x. That's the question. How can I do it? Any idea? Always when there is this type of a question, try to start with the basic definition. That is y less than y. So this is probability f of y less than y is fy of y, yes or no? Do you agree? Y is a random variable again. Any questions? I just found the CDF of y. Okay. So what can I write this as? Y is what? This y is p of f of x less than y. Yes or no? So remember that this is a number which you select and not the small y is a number. I think there's a lag from the tab. Yeah, the small y is a number that you select, but anything on the left side is the random variable. So I can replace the y, which was the random variable, as the function of the random variable. Right? So now do you tell me if it is a f is a monotonically increasing? For every y, there will be an inverse, yes or no? So f of x is equal to y means x is equal to f of y, yes or no? F inverse of y. If monotonically increase a 1-1 function. Yes or no?
Yes, yes.
So what can I write this as? So it's again monotonically increasing. So the inequality also remains the same. I can write this. Fine. Which is what? This is small x, yes or no? We have defined that in this format. Whatever value your f was transforming it to, if you take the same f inverse, you will get the small value of x, yes or no? So which means that it is the CDF of x. So where x is equal to f inverse y. Okay, so now you have told to prove this this differential equation. How do you prove it? The differential equation f of y and f of x in terms of dy dx. What should I do? I will take derivative with respect to y on both sides. So if I take derivative with respect to y on both sides, what will be the left hand side? It will be fy of y, yes or no? The PDF of y. And what will be the right hand side? By chain rule.
Small fx and dx dy.
So we'll use this and see how to do this. But let us now take some examples, a lot of theory. Let us take some practical examples of continuous random variables. So the first example, which is very simple, is a uniform random variable. As I was saying, the computer that you use samples from a uniform 0-1 distribution pseudo-randomly. So their distribution, random variable x is distributed uniform 0-1. It means that the probability of getting any number between 0 and 1 is equiprobable. So can you tell me what its PDF is going to be? So what is its PDF going to be? First, tell me how will you find the PDF? So the f of x is given to you. So do you agree fx of x between minus infinity to infinity should be equal to 1? Yes or no? You have to find the constant c. That's what you're trying to do. Fine. So which can be written as between 0 and 1 c dx plus 0 dx x not in between 0 and 1. Yes or no? By this density function that I have defined. Fine. That is this area under this rectangle actually. This is c into 1, which is equal to 1, which means c has to be equal to 1. Makes sense, right? So this c has to be equal to 1. This area under this curve has to be 1 into 1. Yes or no? Fine.
Yes.
Okay. So now c we found to be 1. Now I'm telling you to find the CDF. How do I find the CDF? First tell me case 1. X is less than 0. What is it going to be? Integral from minus infinity to x, f of x dx. I'm writing down every step. So please, if you don't follow, stop me there and there. So what is this going to be? Between minus infinity and x, if x is less than 0. is going to be 0, right? I have defined it. The PDF is 0 on both sides. Fine. Similarly, I can write between 0 and x, if x is between 0 and 1 dx, which is nothing but x. And x is greater than 1, what will I get?
0.
0. No. X is between 0 and just be a bit careful and tell me what will you get? Is between integral between minus infinity
1.
to x.
1
Yes.
minus
Why
x.
will it be 1? Can you tell me? Because I can write this as my 0 to 1 dx plus 1 to x dx. As you are saying, this is 0 dx. But this is 1, right? The first one. First of all, whenever you thought 0, 1, it cannot be 0 because it is a monotonically non-decreasing function, isn't it? So this is the function, right? Yes or no? Fine. So now you take this derivative and see, you will get this value of x. There's no problem at all. Okay, any questions? If there's no question, we'll come to the second question, that is the expected value of x. So someone now help me with the expected value of x. What can I write this as? Tell me the equation.
Integration minus infinity to infinity x f of x dx. So it's going to be x dx only for
X
0 to 1.
dx 0 to
For
1.
0 to 1, and
This is
if
x
0
square
is
by 2
there,
half. So uniform distributions are so nice that it is like, now I'll give you an intuition. So for the time being, you are all doing maths. Say if I give a scale to you, and if I randomly tell you to throw stones at it, right? Where do you expect? Like if for a far away point, I tell you randomly throw stones at it. Where do you expect the average position of the stone will be? At the center, right? So this is the centroid of the 0, 1. So because it is uniform. So for a beam, the center of mass would be between 0 half. So here also the expected value is at the center of mass. So these are like nice tidbits that you can see. So this f of x is like the center of mass formula, right? In center of mass also you take m dx to be the integral. Here, that's exactly what you're trying to do. Fine. Now, if I tell you to find variance, how do we find it? Variance of x, we discussed last time, is the expected value of x squared minus expected value of x whole square. So let us find the expected value of x squared. What will I use? Which formula? People who were there in the class last time? The lotus, right? Law of the unconscious or unconscious statistician. Right? So this is, what was the formula? The formula was expected value of a function of a random variable is nothing but the function and the same. So you replace x with f of x. It's like the let's write g of x to be particular. So this is the density. Normally, the expected value of the random variable, if it was x, this would have been x. But I have replaced x with g of x. So I just replaced in the right hand side also x with g of x, which is so ridiculous. It doesn't have to be true. But in the last class, we showed that it is true. Okay, so what will this be? The integral between 0 to 1?
x squared
1
dx minus
x
1 by
squared. 1 by 2 squared. This is x cubed by 3 between 0 and 1 minus 1 by 4. This is equal to 1 by 3 minus 1 by 4, which is 1 by 12. Fine. This is the variance. Fine. Great. So now let us try to find an interesting. Let us do an interesting question with these with the uniform distribution. Very nice question. Where we'll be using the transformation of the random variable. Here everything will come into place. So I am telling you that there's a uniform -1 1 given to you. So first of all, tell me what is going to be C here. What is going to be the
Half.
height of this density?
Half.
What is f of x going to be between -1 and 1? Because the integral has to be
Half.
1. Half. This has to be half because the base is 2, the height has to be half. 0 otherwise. So it's half. Fine. So now I tell you that I give you another random variable. So if I sample from this, which gives me y is equal to x squared, something like this. So I tell you to find out the distribution of this y. So how do we find out? That's the question. So now is y a 1 1 function? It is not, right? We cannot use this formula that is given to us. We derived here directly. Why can't we use it? Because it's not monotonically increasing. X square is a first decreases and then increases. Fine. So what will we do? We'll do it step by step. Let's try to do it step by step. So say y again less than y. So y has to be greater than 0, right? There's no question that it can be less than 0. Y is x square. So this is positive. Fine. Okay. Now if y is less than y, what can I write? Again, what is the trick I'll use? I'll replace y with what? The random variable y can be also written in terms of on x. Yes or no? I can write x square less than y. What is the doubt? Please ask me if there is any doubt. Fine. So if this is true, then between what values will x be? Can you tell me? So this is the CDF P of
Minus
y.
root y to root y.
Yes, so it will be between minus root y to root y. So this is why I was telling you cannot use the formula directly. If you use the formula, this would be, you will get only half the side of the curve. So this is, do you agree? By x is minus 1 to 1. So I can just do what? I can write 2 times probability of x between 0 and y. Since it's a uniform, it's a symmetric function. So this is 2 into 0 to root y, 1, rather half, dx, yes or no? The density is half between 0 and y. Okay, this will become root y. Great. So now what will be the PDF? How will I find the PDF? From the CDF? I already know the CDF now. What will be the PDF? So I know f of y is equal to y. So what will f of x be? Sorry, small f of y be? Dy of f of y, which is equal to right. So this is the density that you will get. Something like this will be your density function. Okay. Okay, this is fine. So I am trying, all I'll do is now I'll wait for a minute and ask all of you if you have a doubt, particularly in this question. Then I'll go to the last few distributions and go to the Python code. But I'll wait for a moment. Like if you really ask, please ask the question if you have any doubt. Anything? Any doubt? Okay, I'll wait for 10 more seconds, then we'll go to the next. Okay. Now we'll go to what is known as the exponential distribution. In exponential distribution is like the time you must wait till something happens. So especially in radioactivity and so on, you may remember that there was an exponential decay in the number of particles that actually comes from this distribution itself, where there's a decay is modeled by this exponential distribution. So the exponential 1 is defined as this function. So this is your P of y or the PDF. Right? So at 1, and then it tapers off to 0. And it is 0 otherwise. So now I ask you this question, that is it a valid PDF? So if I ask you, can you tell me how do I do it? Is it valid? So recall, for valid PDF, what does it have to be? The integral from minus infinity to infinity, f of x dx has to be 1. Right? So what is LHS? Minus infinity to 0 is 0 dx, and 0 to infinity is e to the power minus x dx. Fine. So 0. And this term is, what is the integral of e to the power minus x? This is e to the power minus x. The limits will reverse. Fine. Right? So it's 1 minus e to the power minus infinity, which is equal to 1. So it's a valid PDF, yes or no?
Yes.
Fine. So now I tell you to find the expected value. So your variance would be your homework. Find the variance of x is the homework. Find the expected value. So how do I do it? Expected value of x is the integral between 0 to infinity. Again, recall x, f of x dx, which is equal to integral 0 to infinity x e to the power minus x dx. What will I do now? How will I integrate
By
this?
part.
By parts. So I will integrate this function and I'll differentiate this. So when I integrate that, I'll get x e to the power minus x, and the signs will reverse because I'll be negative sign, minus 0 to infinity. The x just vanishes, 1 into e to the power minus x. So this becomes plus dx. Fine. So this is 0, and this we have already seen is equal to 1. Fine. Clear? Which is the expected value. Now I have a question for you. What is the expected value of, what is the distribution of y, or the CDF of y, or x here in this case? Distribution of x is going to be probability of x less than equal to x, which is equal to 0 if x less than 0, or integral between 0 to x e to the power minus x dx. Any question? Which is equal to 1 minus e to the power minus x. Fine.
Fine.
Yeah. So this, now, if I tell you how, so there is a catch here. So if I tell you that to check if the CDF is correct or not, how will you check? Don't tell me I'll differentiate and snatch with the PDF. Say you are only given a CDF and you're told to check.
I'll see if it is monotonically increasing or not.
Monotonically non-decreasing, that is one property. So first you'll see monotonically non-decreasing. This is the first property. Second property is x of minus infinity has to be 0, which is satisfied here, right? Yes or no? And the third
Yes.
property is f of x of infinity is equal to
1.
So just see this, let us draw this graph. So between minus infinity and 0, this is going to be 0. And then 1 minus f of x is, how does it look? So e to the power minus x looks like this. So minus of that will look like this, and you are shifting it 1. So it looks like this, right? This is your PDF. In case you are wondering how I did it, I hope you know how I did it, right? When you take a minus, you reflect it on the x-axis, and when you add a constant, you shift it upwards. That's what I did. Fine. This is how it will look, but that is more calculus than probability, so that's fine. So please do the variance question. So now, in your books, you find not generally exponential of 1. You find exponential by a parameter lambda. Say you have our new random variable y defined as 1 by lambda into x. Fine. This is monotonically increasing function, monotonic function, whatever it is. So I can use the formula. So I am telling you to find the distribution or the PDF of y. So what can I do? Is the question. So let us try and use the property that we learned. So I'm telling you y is equal to 1 by lambda x. Now you tell me if you understood the property, the intuition behind the exponential. If your lambda is higher than 1, what does it mean? Are you expecting it to come faster or slower? Or the thing to arrive? If this was your exponential distributions PDF and you are rescaling it by 1 by lambda, so we'll see what happens. But yeah, try to keep that intuition back in mind, and then I'll tell you why it is going to be that. So now I want to find the distribution of y. What can I do? I can use this formula, right? Yes or no? I think it is stuck for a while.
Yes.
Yeah. So now tell me, what is dx dy?
Lambda.
Lambda. Fine. Dx dy is lambda. Now I also know y is equal to lambda x. So x is equal to 1 by lambda x. So x is equal to lambda y. Yes or no? So I want to find the left hand side over here, that is y's distribution. So I will keep that the same, and the left hand side I will replace x in terms of y. Fine. So this will be fx of x at what value? Lambda y. Yes or no? Clear? I found this. And dx dy is lambda. See, this is non-trivial. So if you have any doubts, please ask. There's nothing to be ashamed of if you did not understand. So now f of x is e to the power minus x. So I will just put the value of in place of x as minus lambda y. So this is the distribution. So and then expected value of y is going to be just 1 by lambda times expected value of x, which is equal to 1. This is 1 by lambda. This is a very easy way to remember. So why I was saying this? So I was telling you it will take 1 unit time to on expectation for your bus to arrive, right? This is 1. But if I rescale it with lambda, this will just come down to 1 by lambda, right? So it will come faster if lambda was greater than 0. Yes or no? That's the intuition I was trying to tell you to have beforehand. Is it fine? Everything clear? Okay. So the final distribution
Means
that
the
will
graph
do
will convert to 0 faster
fast.
and
That
1
is
will shift to 1 by lambda.
That is true. So I am saying that. So remember that this graph is not a. So I think this was O3, right? So 3 is you're saying so
Yes.
it will converge faster. That is absolutely right. It will come to expectation at 1 by lambda. That is fine. But do you also understand that this graph f of x is a density function? That is this gives me a probability of being between a particular range. So let's take let's take this a little bit further and not leave it over here. So I told you expected y is equal to 1 by lambda into x. This is what I told you, and I found the distribution of y to be lambda e to the power minus lambda y. So now if I tell you to find, so let us find fy of y. That is probability of y less than equal to y. What is this going to be? The integral between 0 to y lambda e to the power lambda y dy, right? Fine. So I replace this dy
Yes.
with lambda dy. So I get e to the power minus lambda y 0 to y. So I get 1 minus e to the power minus lambda y. Do you see? So what did I tell you? Y is the time that it took you for the bus to arrive. So say if the distribution of the was the distribution of the bus to arrive was this lambda y. So it was this exponential distribution. So I'm saying that you have to at least wait y minutes, say y units of time. Of time is this. Or rather, am I right? Or the bus will arrive is what I'm trying to say. The probability that the bus will arrive before y. Why is this? So now this is less intuitive. So if I tell you that you have to wait at least y minutes. So then I can say that is the probability of y greater than y. Fine. At least y minutes I told. Fine.
Yes.
That is equal to 1 minus probability y less than y, which is equal to e to the power minus lambda y. Yes or no? Fine.
Yes.
So what is it actually telling me? It's telling me that I am still waiting after y time. So this function is p of y greater than y, or still waiting at y. That is going to become 0 very as we go towards infinity, right? Yes or no?
Yes.
You really don't have to wait. So this is the intuition behind this entire exponential distribution. But again, since I went all this way, so let us do one more small step and tell you the memoryless property of the. I didn't plan to do it, but yeah, property. I did it for the geometric last time, but let's do it for this as well. The memoryless property says that, say if I have already waited t minutes, what is the probability that I have to wait for y minutes more? That's the exponential, the distribution of the memoryless property. So that means that t plus y given that y is greater than t. Fine. This is what I want to find. Okay. T minutes more. What is given? I have waited for y minutes or t minutes. What is the prob that we have to wait y more minutes. So this is y greater than t plus y, comma, y greater than t by probability y greater than by conditional probability definition. So do you agree the numerator, if it is already greater than t plus y, it means it is greater than t, right? It's a subset. So the intersection of this is going to be probability of t plus y. Yes or no? What I'm trying to say is the numerator is an intersection of two sets. That is greater than t and greater than t plus y. So if I take the intersection of this set, set 1 and set 2, what do I get? I get t plus y greater than t plus y, yes or no? I hope it is clear. So this numerator becomes e to the power minus lambda t plus y. I already found this value here. So I'm using this equation by e to the power minus lambda t, which is equal to e to the power minus lambda y. Do you agree this is equal to probability of y greater than y? Yes or no? So which means that if I have waited t time, that information does not give me any advantage that the bus will come faster or not. It's same as starting from 0 again. Okay, so last part of today is the
Dada, can you re-explain that effect of lambda on that bus coming? That I cannot understand that part. Actually.
okay. Let
What
us
you
do it.
told to
Okay, say y was the random variable that was telling me that what is the time I have to wait till a bus comes, right? Fine.
okay. Oh yes, yes.
Okay, so say y is the random variable that tells me the time I have to wait till the bus comes. Fine.
Yes, yes.
So say I tell you now that what is the probability that the bus comes before y minutes? Then that is the integral of this, yes or no?
Yes.
Which is this function 1 minus e to the power minus lambda y, which is the CDF. But now I tell
Yes.
you that you have to wait at least y minutes before the bus comes, which means that y has to be greater than equal to y. Yes or no?
Yes.
Which is same as 1 minus, so this equation. So 1 minus the probability that the bus did not arrive till y. So that is just the e to the power minus lambda y, right? So this is, let me write it
So
down
on
again.
increasing lambda, what is the effect? Means on
That's what
increasing
I'm trying to
lambda.
say. Yeah, that's what I'm saying. So say p to the power p of y greater than y is e to the power minus lambda y, right? So the numerator is the graph will tell me the probability of still waiting at time t. So if I increase y, what will happen? So if I decrease y, what will happen? If I increase y? Lambda, say it's 2 here. If I decrease y, what will happen? Lambda equal to 4. This graph will just fall off faster, right?
Yes. Yes.
Yes or no?
Yes.
Which means that so the probability that you're still waiting will become much smaller and a smaller time. Look at this time window. The probability is much smaller. Yes or no?
Yes. Actually.
That's what I was trying to say. Fine. So let's do the last thing. I'll not prove the thing for normal distributions, but I'll give you because this is there. I have given the reference in case you're interested. We're not going to do a lot of normals in RL, so I'm not going to go into it again. But I have done it twice before in previous 2 courses. I'll give a link of this in the video. You can go and look at it, the details of how to find the curve and so on. But I'll give you the intuition of what the thing is. So the density of a normal distribution is given by this weird constant. You can see how we are deriving it, but it doesn't really matter. The constants really matter. It's just a proportionality constant. So if I tell you, this is also known as the bell curve. So this is known as when it's distributed as normal 0, 1. Fine. So normal 0, 1 means, so what can you tell me? What will be the density? What will it look like? So anything value greater than, so add 0, this is going to be 1 by 2 pi. As you go towards infinity, it will decrease, yes or no? Fine. E to the power minus z will decrease. And now it is z square, so it will be symmetric across the x-axis, the y-axis, I mean. So this will be this, right? Fine. This is how the bell curve looks like. I'll show you it in a histogram also, but anyways. So the question that we try to answer here is, why do we study? So this is the most important form of distribution in the entire statistics. Anything you're going to do is normal at the end of the day. So look at this graph that I have over here. So does this give you some idea of why is it important? So say this is the mean. This is the mean of the random variable, mean. So 0 is the mean, you can clearly see here, because it is symmetric across both sides. We'll see, we'll prove it, but 0 is the mean. So it says that around 1 standard deviation around the mean, 65% of the data is present. 2 standard deviations around the data, 95% of the data is present. And 3 standard deviation of the data, 99% of the data is present. So this is the basis of statistical tests as well. So which it is not there this time, but last time I had done it. So this is also known as the 65, 95, 99 rule. Which means that, say you have a class, I'll give you this intuition. So you go and check everyone's height and you plot a histogram. So all you will get is the height histogram will look like something like this. Yes or no? Somebody will be very tall, somebody will be very short, but most of the people will be near the mean, right? So most distributions in nature would follow this mean, this property of a normal distribution. That's what we're trying to refer here. Fine. So let's find out some properties of the normal, like the mean and the variance. Then it will be very easy for you to easier for you to understand. So now tell me expected value of the mean. I will give you a computer example simulation, then you'll visualize it better maybe. So say expected value of x you want to find, or z here in our case. Z is distributed as normal 0, 1. So what is how will I write expected value of z? Z by 2 pi e to the power minus z square by 2 dz, right? Yes or no? Right?
Yes.
So what is this going to be? Can you tell me just by looking at the graph? Looking at the function?
Minus e to the power minus z square by 2 by root 2 pi.
That is fine. You can integrate it and fine. That is right. But without integrating also you can say and match my point. Can you tell me? See, this is an even function, right? And you're multiplying an odd function with it. So everything that will be on the x is the z is an odd function. Yes or no? So you'll have symmetric on the.
It will be 0.
Yes, because it's an odd and this is an odd function. Odd into even is an odd function. And whatever I don't know who said, that is also fine. Antariksh said anything. Okay. So, but let's do variance. There you'll need to calculate the thing. So for variance, I will calculate E of z square first. What will be E of z square? Minus infinity to infinity, z square e to the power minus z square by 2 pi. Fine? Dz. Now your trick is going to work. So I will write this as z e to the power minus z square by 2, right? into z by 1 by 2 pi. Fine, it's again an even function, so I can just take 2 outside. But the point here is, which one will I integrate, which one will I differentiate? That's the point. Can you tell me? So this one, I think he told me I can integrate. So I will differentiate this. So how can I integrate this? Z e to the power minus z square by 2 dz. Can you tell me?
It's just e to the power, the integration
Yeah.
is minus e to the power z square minus to the power minus z square by 2.
This is what you did, right? I just made z into t of z square by 2. So it's just e to the power minus z square by 2 negative of that. So I get z e to the power minus z square by 2 from 0 to infinity. And I have another term minus. So this becomes 1 into the integral of e to the power minus z square by 2 dz. Now is the trick between 0. Let us write minus infinity to infinity dz. 1 by 2 pi. I will not put a bracket. So the first term, what will it be? The first term will go to 0. At 0, this is 0. 0 into e to the power minus z square by 2. And at infinity, it is infinity by e to the power minus infinity square by 2, which is by limit, you will go to 0. Because e to the power z square is a faster decreasing function. You can use L'Hopital, but it's not required. It's clearly 0. Now, can you tell me what is this going to be? This is going to be, I think we have defined the PDF as this. So the integral from minus infinity to infinity of the PDF is just 1. Yes or no? We don't need to compute this integral. Question, Sharon? You're not audible, but you. I think there's some problem with your mic, but yeah, others can hear me. Fine. So
Yes,
the variance of x is going to be 1 minus expected value of x whole square. This is equal to 1. So all this while we have been using variance, but variance, what is the dimension of variance? Can you tell me? So if this is unit, x is in terms of some units. So variance is the expected value of x minus mu whole square, right? So it's unit square, yes or no? So to find distance, we'd rather take the root of that. So standard deviation is d or sigma is defined as root over of the variance. So it's still 1 over here. Fine. So that's why this is also known as z is known as normal 0, 1, where 0 is the mean or the mean of the distribution and 1 is the variance. Fine. Okay. Let us do a transformation now, and then I'll go to last thing after that. Good. So now I saw that the mean and the variance is given to me in terms of 0 and 1. But I don't know that every time I do say I am calculating height of a class, distribution of the heights of a class. So then will it actually work with 0 and 1? It will not work, right? Then I need a mean class height, say 170 centimeters or 165 centimeter, and I will need to have a standard deviation around it. Yes or no? Is it fine? So all I'll do is I will rescale this 0 and 1. Z is between normal 0 and 1. I'll rescale that and I will add a constant. That is the mean. Now can you tell me what is the expected value of x? The expected value of x is By linearity of expectation, expected value of mu plus sigma into expected value of z. What is the expected value of z?
0.
0. And this is a constant, that is mu. Again, now let us calculate the variance of the distribution. Variance of x is expected value of x minus mu whole square. So this is expected value of mu plus sigma z minus mu whole square, which is expected value of z square sigma square, which is a constant again. What is the expected value of z square, which is equal to 1. This is sigma
1.
square. So you see, yeah, so the variance is sigma square. So you can control, so taking just a normal 0, 1 distribution, you can create a normal distribution with mean mu and variance sigma. Variance equal to sigma square, where sigma is the standard deviation. But all this is all fine. But my question to you is, but what is the density of this distribution? All this data you told me that mean and standard deviation is there, but it is not looking like a bell curve. I can only see the mean and variance. That too many things, or every distribution has mean and variance. Why do you say it's still a normal distribution? So how do I get the distribution? Can you tell me? X is equal to mu plus sigma z, right? So now I have to calculate the distribution of x. What will I do? Yes or no? Again, it's a 1, 1 function. I can do it. And it's increasing as well. So dz dx is what? 1 by sigma, yes or no? Fine. So what is z? Z is x minus mu by sigma. So now I just put this value over here. So f z of x minus mu by sigma d1 by sigma. So what is this going to be? Tell me. 1 by 2 root 2 pi e to the power minus x minus mu by sigma whole square. Sorry, x minus mu by sigma whole square into half. Yes or no? Fine.
Yes. Yes.
So this is this is also a same formula. This is the same idea of a general normal 0, 1 distribution. Fine. The last, we will do a last question and then we'll go to the computer program. Okay. The question is, say y is equal to z square. So this is also known as chi-square 1 distribution, but let's not worry about that. Say y is equal to z square. So what would be the PDF of y? Can you find it out for me? I already did a similar question. So how will I find out first? See, again, this is not a 1, 1 function. So I need to use the fundamental property, that is write down the CDF. Yes or no? Okay. So now next step, what will I write? Z square less than y, yes or no?
Yes.
So which means that probability Z is between, again, same
Minus
thing.
root pi to root pi.
Okay. Fine. This is going to be 2 times. So this is an even function. 2 times probability Z less than root y. Yes or no? Between 0. Let's just write it down. Anyway, so the integral is minus root y to root y e to the power minus z square by 2, 1 by 2 pi dz. Yes or no? Just wrote z is normal 0, 1. Just put the value here. So which is symmetric. So I can just remove minus root y here and put 2. So now I'm told to find the CDF. See, this is non-integrable form. The normal distribution cannot be integrated. You have to use Simpson's or trapezoidal rule to find the numerical distribution. But f of y I can find. How can I find? F of y
By
is
differentiation.
by differentiation. Very good. So what will I get? I will get, just put the value, e to the power minus root y squared by 2 into 2 by 2 pi into the derivative of d dy of root y, right? Which is equal to 1 by 2 pi y. This is 1 by 2 root y e to the power minus y by 2. Fine for everyone. This is just go over all these once. And once you go over all these, try to do them yourself once. That will give you a good hang of things. Okay, the last thing, if you have no questions, I'll go to the why the normal distribution is so beautiful. The normal distribution has this wonderful property called the central limit theorem. I'll give you the link to the last time's video, what is central limit theorem and so on. The central limit theorem tells me, just maybe copy this part. I'll put it at the end. This is going to be used a lot in reinforcement learning because we'll be finding out law of large numbers a lot. So we will not do the calculations, but we'll be using this property a lot. So pay attention. So there is the space. No, this is right at the end. Okay, so what does the central limit theorem say? Say you have samples drawn from a distribution which has mean mu and standard deviation sigma square. I think people who do a little bit of data mining would use this all the time for normalization. So you'll see why. See, so if this data, this x1, x2, this is data that you have, say height of a person, height in a class, height of students in a class. The height of students, these are x1 to xn. These are IID heights. So what I'm trying to say is, and it is given that each of these random variable has a mean mu and a standard deviation or variance of x1 is sigma squared, right? So what is it to what we say here is we say that say we define a mean random variable, which is the mean of all these random variables, right? That's the sample that you got from. So these are IID random variables, and you define a mean of the random variables. That is, you take the sum and take the weighted average, right? This is average, yes or no? Do you agree? This is summation of xi's by 1 by n. So I'm saying the average of all the random variables. When I take the average, I subtract the mean and then divide by the standard deviation. This converges to normal 0, 1 in distribution. This is also known as law of large central limit theorem, and it comes by law of large numbers. Let us see what does it mean. So first of all, tell me what is the expected value of x bar? First question. Can you tell me which is the expected value of 1 by n summation of I equal to 1 to n xi square? What can I use here?
Linearity.
I will use linearity. So 1 by n summation of I equal to 1 to n x1, because there's an IID plus linearity. Identically distributed, so x1 is equivalent to x50 or xn. So it's like this. So I told you last time that it is like tossing 50 coins is same as tossing the same coins 50 times. So this I already is given to me in the question. That is mu. So it's n mu by 1 by n. So this is the mean of this, the mean of the, so the expected value of this, the mean vector, the mean random variable goes to the actual, goes to the expected value of each of the i's, right? That is fine because each of the xi's were given to be sigma of mu. Now I am telling you to find the variance of x bar. So what is the variance of x bar going to be? So for independent random variables, what is variance of x1 plus x2 going to be? Can you tell me?
Sum of variances of individually.
Can we prove it? So this is expected value of x1 plus x2 whole square minus expected value of x1 plus expected value of x2 whole square. Yes or no? So just in case you're wondering how I got this, this is fine. This is the variance formula. So I just use linearity to get this. So this is x1 squared plus expected value of x2 squared plus expected value of x1, x2 minus expected value of x1 whole square minus expected value of x2 whole square minus expected value of x1, expected value of x2. So now see, I group these two. I group these two. I get variance of x1 plus variance of x2 plus 2 times expected value of x1, x2 minus expected value of x1 into expected value of x2. So this is known as the covariance. But x1 and x2 are independent. If they're independent, I can write this as x1 expected value of x2. This is your homework. If expected value of x1, expected value of x2, if x1 is independent of x2, please write this in the homework. This becomes equal to, you can pull them out. I have already done a variation of this last time by pulling out what is known and so on. This goes to 0. So there's a sum of the variances if independent. So now tell me, what will be the variance of x bar be? That is the same as variance of 1 by n summation of I equal to 1 to n xi. So we saw that variance, if you multiply a scalar, you get the scalar just goes out with a square because expected value of x minus mu whole square, right? And when you're multiplying a scalar with it, scalar c, so everything will be scalared by c. So you'll get c square variance of x. That's the idea. So this n I am pulling out with a square. Is it clear? Do you want me to write it down once again? So say y is equal to c of x. The expected value of y is equal to x, c into expected value of x. Therefore, cx minus c expected value of x is the variance of y, which is equal to c squared expected value of x minus expected value of x whole square, which is equal to c square variance of x. So if you multiply with a scalar, it just the scalar can go out as a square. So do you agree? Then I will have a summation of by linearity because there I independent. Just now I proved I equal to 1 to n variance of xi. So the numerator, what will it become? N times sigma squared, right? Yes or no? I told variance of this each of is sigma squared. And so I get the variance is equal to sigma squared by n. So the standard deviation of or the sigma of x bar is equal to sigma by root n. So what do you see here? Do you see some pattern? So do you see that sigma bar goes to 0 as n tends to infinity? Yes or no? Right? which means that X converges to the mean. So X bar converges to the actual mean. So this is called the law of large numbers, or the weak law of large numbers. There is no variation actually. Sigma is 0. That is no standard deviation, no variation in the data. So what does this actually mean? It means that in terms of intuition, it means, can you tell me what does it mean? That sample mean goes to actual mean as you take lots of sample, isn't it? Okay, so we saw that. So what is the mean of the distribution? Mu of X bar is mu, still mu, right? And what is the sigma of X bar? That is sigma by root n, yes or no? Fine. What was the normal distribution formula? It was X minus mu by sigma, yes or no? Do you agree? Where X was normal mu sigma squared, yes or no? And this was normal 0, 1. Fine. Okay. So I am saying that this X bar minus mu X bar by sigma X bar also goes to normal 0, 1. So this is called the central limit theorem. You will not appreciate it unless I show you the graph. But the idea is, if I take the class average, normalize it, and put it in a bell curve, it will always converge to the normal distribution if there are enough data points. Any questions? If there are none, I'll show you the equation, or I'll show you the simulation using Python for the central limit theorem. Right? Okay, feel free to stop me. I'll stop sharing from my tab. Okay, so now I'm sharing my computer screen. Still, let me know if you can see. You can see, right? I now can't see all of you, but you can see my screen, right?
Yes.
So, so I'm telling you that the last part, where is it? Yeah. So I'm saying that the mean of the distribution minus the mu by the standard deviation is going to go to normal 0, 1. So I have given a simulation question over here, which says that, say, let xi be sampled from uniform 0, 1. Fine. So I'll just get this. So this will be a bit acquainted with Python. It will help you a lot. So NumPy is a package that helps you do all this calculations easily. So I'm saying sample. So I will just load these two, this plot lib function and all, the histogram function. So say I sample. Here I sampled 1 lakh points, right? Or 10 lakh points, 10 lakh points from the this distribution, 1,000,000 points from this now uniform 0, 1 distribution, right? So it will be like this. Do you agree? And I plotted the histogram. Fine. Everybody is okay with me now. So I was telling you the density will be the same as the histogram. So these are samples, but it is going to what we had expected, right? In theory. Yes or no? Fine.
Fine.
Yes.
So now I know the mean and variance. 0.5, variance is 1 by 12. Okay. So now, say what I'm trying to do currently is I'm trying to bin the data. So I'm trying to make averages. So I cannot plot a histogram unless I have multiple samples for the x minus mu by sigma, right? I cannot plot a histogram. I cannot plot it with one. Yes or no? So x minus mu by sigma, I want to plot, I want to get multiple values for that. So what I do is I select randomly 200 data points from this 1,000,000 points. And what I do is I rescale them. I do mu starting from for each of them, mu minus the actual value, that is the sample value, minus the mean and divide by sigma. So I'll just write it down over here. So I am rescaling as u minus mu by sigma, where u is the samples, by sigma root n. Sigma by root n, where you are samples from uniform 0, 1. So, and then I just plot the histogram of that. Just see. So this this uniform distribution, when I just rescale it, and that starts looking like just like so this is a normal deviation when I sample from the normal distribution and plot it. This is just when I sample from normal distribution and plot, versus when I do all the transformation and I plot it. This is x minus mu by sigma root, and I've already written it in the x-axis. Similarly, on the y-axis, see both the distributions exactly look the same. So any questions do you have regarding the implementation or anything? Or I'll stop recording. I'll stop sharing my screen. I'll wait for a moment or two. So I'll just explain this code once again. So mean and sigma I stored. I divided the entire, so I have 1,000 data points, 1 million data points. I divided these data points into how many? So I'll just add so n by b. That is around 5,000 samples. So I'll get 5,000 samples, and I plot 5,000 samples using a histogram, right? And I guess see that it's the same distribution as we would have got if we had just plotted it theoretically using normal density, which means that if there are enough data and I normalize them, the distribution ends up looking like a normal distribution. I hope it gives you the motivation and intuition. Please go over this. You have some time now, and then we'll begin with joint distributions the next day. And we'll finish it off. We'll finish probability next time, and we'll start with reinforcement learning next Wednesday. So any questions do you want to ask regarding this, regarding what we learned today? Anything, I'm okay to share the screen and try to explain. I'll wait for a moment, a minute. Okay. So don't feel shy to ask questions. Because these are not trivial things, especially for people who are just joining. Okay, I'll stop recording then. Okay, any questions?